Hello, I'm Nicole Cesar. I'm going to be discussing about medium access protocols. So first, there are two kinds of network. One is point-to-point and the other is broadcast or multi-access network. Point-to-point network, there are two stations occupy each end of the medium. Data is passed to stations in between source and destination of data, if any. So why is there the if any on the last part of the sentence? Because in the ideal world, most of the stations don't have a direct path for each other. So data may pass to different paths where there are stations in between them. So from the source station, the data will be passed to another station, and go so on and so on until it reaches the destination. So now, broadcast or multi-access. Multiple stations occupy a medium. All stations connected to the medium can hear or see the data, but only the intended destination should fetch. So why is this so? So this is like calling someone across the street. Maybe a lot of people can hear what you're saying or how do you call that someone, but they don't give attention to what you're saying because they're not the intended destination of your message. But the person you're calling would acknowledge you because he or she is the intended destination of the message. Last is effective utilization of expensive resource and high degree of connectivity among stations. So multi-access protocol have four classifications, which are fixed assignment, random access, demand assignment, and adaptive strategies and mixed mode. First, fixed assignment. It allocates channel in a static fashion. Don't adapt to various activities of the station. So it has three types of channel allotment. It's frequency division multiple access or FDMA, time domain multiple access or TDMA, code division multiple access or CDMA. So first, what is FDMA? It confines the data in a frequency band. Can transmit anytime on the frequency band. So what are the examples? Radio and television. So how the radio and television became FDMA? So as you can imagine, in the radio stations, that there are a lot of frequencies, just like 99.1, 102.5. Those are the frequencies. So in FDMA, it assigns a certain frequency to a radio station, and the radio station is always transmitting its message to that frequency. So you can see, as a listener, you can transfer to different frequencies, and all the data coming from those different frequencies are just coming from the radio station where these frequencies are allocated. So that's the same with the television. You move from different channels, but each channel is unique to each television station, and all the data coming from that frequency or channel comes from a specific television station. So next, CDMA. Fixed time slot for each station. Cannot transmit other than the assigned time. Then transmission is stopped when time runs out. So what's the difference between FDMA and TDMA? So in TDMA, rather than frequency is allotted. Here, time is allotted. So once a station is given a time to transmit, he or she, the station can only transmit on that specific time. Other than that, the specific station cannot transmit. So next is CDMA. So it is unlimited on both frequency and time, known as speed spectrum. It uses frequency hopping and immune to frequency interface. So how is that so? So on the next slide, there's this diagram. So this diagram is CDMA diagram. So as you can see, it is a plane where the x-axis is the time and the y-axis is the frequency. So you can see the data transfer from different frequency across time. So this is very hard to intercept because it is very unpredictable. That's why this kind of method is being used by the military. So let's go to the second multiple access protocol, which is random access technique. So the channel is allotted to stations randomly. Collision may happen and can be improved by using different methods. So why does collision may happen? An example is we have multiple stations trying to access the channel, but two stations are allotted randomly at the same time or the same frequency. So when that happens, collision of data will happen and the data might be destroyed or damaged. Here are some examples of how to improve random access technique. First is Pure Aloha. It's developed by University of Hawaii. It uses packet switching broadcast network using radio channel. Then its goal is to provide cheap access to one or more timeshare systems. So how does it work? So first, the terminal allows station to transmit if there's data to transmit. Second is terminal ignores garbled or destroyed data. Terminal sends acknowledgement for all data in good form. Then station retransmit data if there are no acknowledgement received within a predefined period of time. So when a station transmits, if the terminal receive the data in good form, it will send an acknowledgement. But if not, the station retransmit after a predefined time because there's no acknowledgement that happens. It means that the data is either destroyed or not in good form. The next is slotted Aloha. So it is based on Pure Aloha, but this time the time in Aloha is divided into slots. Then these slots are assigned to a station. Then the station cannot transmit if the time slot is not allocated for that station. So the next is Carrier Sense Multiple Access or CSMA. In here, it allows users to hear each other. Has two protocols, non-persistent and pre-persistent. So non-persistent this is how non-persistent handles the transmission. First, if channel is idle, it transmits data. The next, if channel is busy, it reschedules its transmission of data. In P-persistent, if channel is idle, it transmits data with probability P. Then if channel is busy, the terminal waits for the channel to be idle and immediately transmits. Next is demand assignment technique. So this is the third multiple access technique. So the channel is allocated based on the needs of the station. Stations are required to announce their requirements. The central controller decides who can use the channel. The next is allocates the channel based on explicit demands of the station. Next, there are two types. One is that requires central controller. The next is with distributed control. So requires central controller. So in this way, it requires central controller that would allocate the requesting station or machine the channel. So here are some of the examples. Polling system. Polling system is where central controllers poll each station. Another response or negative reply means that station has nothing to transmit. After station transmits, central controller polls the next station. Efficiency is determined by round-trip delay in small and polling message overhead is low. So what does that mean? So if the inquiry of the central controller to a station takes a long time, then it is not efficient because there will be a lot of delay between transmission since the reply or the reply from the hold station is too long to arrive. So it uses FDMA or TDMA channel that are assigned based on demand by the controller. A station that requests to transmit selects a channel randomly. The channel is on a downlink. It has been allocated for a station, and others should refrain from using it. If collision occurs, stations try again on a later time. Once transmission is done, station sends a deallocation message. Now this is the fourth multiple access protocol technique, which is adaptive strategies and mixed node. So in this strategy or technique, it uses the different techniques or protocols that we discussed earlier. Then it adapts to varying needs of stations. So now let's move to the next chapter, which is IEEE 802 LAN standards. We'll focus on two LAN standards, which is IEEE 802.3, which uses CSME. We discussed that earlier. Then the next is the 802.5, also known as token ring. So first, let's discuss 802.3. So this allows independent computers to communicate to each other in a small area. Then it has a moderate to high data rate. So the MAC sublayer protocol. It is based on one persistent CSMA or CD LAN. In CSMA or CD model, it has three states, which is idle, busy, and collision. A collision is detected if the value received from the channel differs from the data being transmitted. So then it uses exponential backoff algorithm if a collision happens. Then let's go to the physical layer specifications. So this is the format of the physical layer. The first part is data rate in Mbps and medium type or signaling technique. The next is max segment length per 100 meters. So some of the examples are 10B base 5, which has a data rate of 10 Mbps. Then the medium type is base. Then the maximum segment length per 100 meters is 5. So here are some of the characteristics. It is 10 mm thick, or as thick as a garden hose, and connected by using vampire fang. So this vampire fang is something like a clip that looks like a vampire fang to connect the wire. So next is less impedance and signal degradation. Can be used for long distance. Since it's very thick, impedance or any, let's say, magnetic wave could be very hard to get into the data because it is very thick. That's why it is used for long distance. Next is 10 base 2, 5 mm thick, uses BNC connectors and T-junctions, and uses bus topology. The next is 10 base T, requires shielded twisted wires. Cable runs through a central hub. Any breakdown in the network doesn't affect all of the stations, but hubs can be very expensive. So why does any breakdown of the network doesn't affect all the stations? This is because every data or every station runs through a hub. So once the one path or wire is disconnected, it doesn't affect other stations because the wire can only affect a station because most of the station is connected to a central hub, where the central hub is their common connection between stations. So if the central hub goes down, that is the time where all the station can be affected. Let us now move to 802.5. So 802.5 uses ring topology. So ring topology is a network where each node connects to exactly two nodes, forming a circle. So what does that mean? So imagine a bead or a necklace of beads. So that's a ring topology because satisfy that each node is connected to exactly two nodes. So as you can notice about that is if you choose one bead, it has two beads beside it, one to the left and one to the right. Next is max sub-layer protocol. Uses ring interface, has three modes, which is listening, transmit, and bypass. Listening mode is where it copies the input into the output. So transmit mode is it breaks the connection between input and output, allowing to enter its own data. And bypass mode happens when ring interface is powered up, enabling data to pass through without delay. Then how the data is transferred. So first is there's a token circulating in the ring when all stations are idle. So when a station wants to transmit data, it seizes that token and changing a bit in the token. So transforming the token indicates that the station wants to transmit data. Then the token is transformed into a header of a data frame. So when a station is not the intended destination, it puts back the data into the ring. So since all through the ring, passing the data would require that the data pass to different stations until the destination. So the data would be checked or listened by the station where it passed, then checks if it is not the destination of the data. It put back the data to the ring or passes the data into the next station. If it is the intended destination, that station changes into transmit mode. When the destination station cannot remove the data frame, but it adds some bits into it. If there happens an error that the source station didn't remove the data frame, a guard station detects if it revolves around the ring twice. So if this guard station always listens to all the data frame on the ring, then it records the details of that data frame. So once it detects the data frame that it passes through this guard station twice, it deletes that data frame, then added another token. Physical layer specifications. This requires shielded or twisted pairs. Originally, data rate is 4 Mbps, but IBM later on introduced a 16 Mbps version. It follows the Manchester encoding, which is 3.5 to 4.5 volts. This is the part of a frame. As you can see, the token has three parts, which is SD, AC, and ED. So this is the token revolves around the ring. So as stated earlier, once a station wants to transmit, we transform that token into frame, which is the bottom part of our illustration. As you can see, the first part is the token, then the other parts are specific to the station. Now let's move to the last part of our discussion, which is network layer and Internet protocol. Network layer is concerned about moving the data frame from the source to the destination. The network layer handles the difference if the source and destination are from different networks. So it provides service to transport layer, namely connection-oriented service or connection-less service. So what's the difference between connection-oriented and connection-less? Connection-oriented is made from the belief that subnet should provide a connection-oriented service for reliability, while connection-less is from the belief that the subnet is unreliable and should just be given minimal tasks. The next is connection can be established on connection-oriented if there's already a circuit in place. On the other hand, connection-less uses the premise of sending a data, hoping that it will reach the destination. The next is the creators of connection-oriented believe that users should not be bothered by the connection system and should only be provided with simple, reliable service. While the creators of connection-less system believe that since most of the computers today are powerful enough, there's no reason that the complexity should be passed into them. Now, the routing algorithm. So what is routing algorithm? It finds the best path for every datagram in connectionless service. Different algorithms have different priorities. So some emphasizes on simplicity, while others emphasize stability and robustness. Non-adaptive are algorithms assign routes in a static manner. Then adaptive algorithms are algorithms that provide routing based on traffic and topology. So what's the difference? Non-adaptive since it assigns routes in static manner, if there are traffic or the topology changes, there would be problem because it only knows a specific route or path to the destination. So shortest path routing. It finds the shortest path between two nodes. So an example is the Dijkstra's algorithm and distance vector routing. Now let's go to internetworking. So what does that mean? It is the network of network by interconnecting different networks. To connect a network, it uses various black boxes. So what are these black boxes? These are repeater, which is copies bits from one segment to another. A bridge, which stores and forwards data link frames from one LAN to another. Router translates packet between one network to another, which may have different protocols. So some differences between networks: the protocol, the address, packet size, flow control, accounting, and services offered. So the internet protocol. So what I guess is you could always hear internet protocol, but what does that mean? So internet protocol is connectionless. It just encapsulates and sends the data. Doesn't make up for lost or damaged packet, and there are no facility for end-to-end data reliability, like sequencing, flow control, error control, retransmission, etc. So you can remember, connectionless doesn't track the frames it sends. It is just hoping that the data it sends will be received by the destination. So that's what internet protocol is. So IP diagram has four major functions. First is to provide basic unit for data transfer, provide addressing, facilitate routing, perform fragmentation. So here is a diagram of an IP. Then addressing. IP datagram identifies its source and destination by address field. No two machines connected to the internet has the same address. Address field is 32-bit wide, and IP address has 5 classes. So here are the 5 classes of an IP. Class A, B, C, and D. As you can see, it has different parts. So, IP. IP is written in dotted decimal notation. Lowest IP address is 0.0.0.0. And the highest IP address is 255.255.255.255. IP addresses has 2 portions, network address and host address. So let's move to the last part of our network layer internet protocol, which is the subnet. So given the situation, you have one IP address, but you have to connect 5 computers to the internet. So how will you do that? Maybe you can transfer the IP address from one computer, but not all 5 computers could connect to the internet. So this is where subnet appears in the picture. So what does subnet do to provide internet to 5 computers having one IP address? Subnet, what happens is subnet divides the network into smaller networks. So these smaller networks would be our 5 computers. So in this way, the network has one IP address, but the subnetworks or the broken down networks, which is our 5 computers, have their own IP address using subnet mask. So when a computer sends data to the internet, the subnet handles that data going to the internet. So once the internet sends the data to the specific computer, that data has details about the subnetwork or the subnetwork where it intended to go. So once the internet sends the data to the subnet can now identify the destination computer. Then the subnet is the one who sent the data to the specific computer. So that's how subnet works. So now almost all TCP/IP networks use a subnet. Then this allows for the efficient use of IP addresses. So that's the end of my discussion. Thank you for listening.